Hello students, secondary 1 chemistry. We are in unit 3. The lesson now is the colligative properties of solution. If you have a solution such as water, alcohol, benzene, any liquid, oil, for example, any glass, the region directly above the surface of the liquid has vapors of this liquid. When this glass is covered, these vapors condenses to a liquid and other molecules of the liquid evaporate, and this process continues, and we say that there is a dynamic equilibrium between the vapor and the liquid. This vapor exerts pressure on the surface of its liquid, and we say that there is a vapor pressure. What is the vapor pressure? The vapor pressure is the pressure that the vapor affects on the liquid surface when it is at equilibrium with the liquid inside a closed container at a constant temperature and pressure. This is the definition of the vapor pressure, as it is here. The pressure of this vapor on the surface of the liquid at constant temperature and pressure. This pressure of the vapor is called vapor pressure. If you heat this liquid, the quantity of the vapor of this liquid increases gradually until the pressure of this vapor on the surface is equal to the outer atmospheric pressure of the air here. If the pressure of this vapor is equal to the atmospheric pressure after heating, we say stop. This is the temperature of boiling, or the boiling point of this liquid. The boiling point of this liquid, the temperature at which the vapor pressure of this liquid is equal to the atmospheric pressure. Okay, this is the boiling point of this liquid. If there is a weight or any other force on the outer surface here, on the water, and we heat, the vapor increases, the quantity of vapor increases gradually until the vapor pressure of this liquid is equal to the external pressure, which is not necessarily here the vapor pressure. It may be other pressure, maybe atmospheric pressure plus other pressure, like this way. The temperature at which the pressure of this vapor is equal to the outer pressure is called the measured boiling point. Of course, this temperature is higher than the normal boiling point of this liquid. So the measured boiling point is the temperature at which the vapor pressure of the liquid equals the atmospheric the pressure exerted or acted on it. So you must review this definition: vapor pressure, natural boiling point, measured boiling point. What about melting point? The temperature at which the substance changes from the liquid state, from the solid state to the liquid state. When you dissolve a solute in any liquid, the vapor pressure of this liquid solvent changes. The boiling point of this solvent liquid changes. The freezing point of this liquid solvent changes also. These properties are called colligative properties of solutions. These are the properties which changes when you dissolve any solute in this liquid or solvent. So the question here is which of the following is not a colligative property? Which one is not a colligative property? The solution in water is not a colligative property. Here is a comparison between the pure solvent and the solution. The solution is this pure solvent plus the solute, which is written here as red circles here, or orange circles. When you dissolve the solute in the solvent, there is an attraction between the molecules of the solute and the molecules of the solvent. So the quantity of the molecules above of the vapor above this solution is smaller than when it is pure solvent. So the quantity of vapor decreased and the vapor pressure of this liquid decreases as a result of the solution of this solute. So here the vapor pressure in the pure solvent is high, while in this case of solution the vapor pressure is low. In the same way, boiling point. Here nothing prevents evaporation, but here attraction between molecules of solute and solvents decreases the vapor. So you need more heat to increase the vapor here. So you note that the boiling point is higher in the case of the solution than in the pure solvent. Also the freezing point of this pure solvent is high, while after dissolving a solute in the same solvent the freezing point decreases. Why? Because the attraction between molecules of the solute and the solvent prevents attraction between molecules of the solvent and hinders the solidification process. So you need more cooling, so the freezing point decreases. These graphs represents what happens: the vapor pressure of the solution and concentration. As the concentration increases, the concentration is the represent the quantity of the solute increases, the vapor pressure of the solution decreases. This is an inverse relationship. This is also the relation between boiling point and concentration. As the concentration of the solute increases, the boiling point increases due to the attraction between molecules of solute and solvent. Here is also the relation between freezing point of solution and the concentration. As the concentration of the solution increases, the freezing point decreases, as I said before. For example, if you have pure water, the concentration of the solute is 0. Pure water means no solute is present, 0 molal. The boiling point of this pure water is 100 degrees Celsius, and the freezing point is 0 Celsius of the pure water. When you dissolve glucose sugar in this water, if the concentration of glucose is 1 mol, and this means that you dissolve with 1 mole in 1 kilogram of water, the boiling point increases to 100.5. 0.5 is the increase in the boiling point. If you dissolve 1 mole of the solute in 1 kilogram of water, and the freezing point not 0 as it was in the case of pure water, the freezing point decreases to minus 1.86 Celsius. This means that decrease in the boiling point. This is due to the dissolution of 1 mole only in 1 mole of glucose in pure water. If you dissolve other substances such as sodium chloride, you know that sodium chloride dissociates in water. When you dissolve 1 mole of sodium chloride, 1 mole of sodium chloride in ACl in 1 kilogram of water or any quantity of water, sodium chloride dissociates completely to 1 mole of sodium ions and 1 mole of chloride ion, complete dissociation. This means that there are double mole, 2 moles, 1 mole. No, after dissociation, the quantity of particles is 2 moles, 1 mole Na plus and 1 mole Cl minus. So 2 moles. This means that the the freezing point of water will decrease, will not become minus 1.86 but by 2, because this salt dissociates into 2 moles. Okay, 2 moles means this decrease will be multiplied by 2. This gives minus 3.72. If you dissolve 1 mole of calcium chloride, you know also that calcium chloride in water dissociates to give 3 moles. Of course, this is 1 mole, but dissociates to form 3 moles. 1 mole of calcium and 1 mole of chloride and another 1 mole of chloride. This means that 3 moles. 3 moles, this means that the decrease will not be minus 1.86 but multiplied by 3. This is due to 1 mole. This is 1 mole but multiplied by 3. Glucose never dissociate, so the concentration remains 1 mole. But here 1 mole of calcium chloride dissociates to form 3 moles of particles. So this decrease is multiplied by 3 to give minus 5.58 moles. Okay. In the same way, the boiling point. The boiling point of pure water is 100. But after dissolving 1 mole of glucose, the boiling point increases, not decreases, increases by half degrees Celsius. So the boiling point of solution of 1 mole of glucose in 1 kilogram of water is 100.5 degrees Celsius. If you dissolve 1 mole of sodium chloride, and the sodium chloride, as you know, dissociates into form 2 moles of particles, sodium ions, and 1 mole of sodium ions and 1 mole of chloride ions, so 2 moles. This is 1 mole dissociates into 2 moles, so the increase in the boiling point will be half multiplied by 2. So the boiling point of this 1 mole sodium chloride solution in 1 kilogram of water, the boiling point will be 101 Celsius. In the same way, if you dissolve 1 mole of calcium chloride, and you know that calcium chloride dissociates in water to form 3 particles, calcium, 1 calcium mole, and 2 moles of chloride, so the total is 3 moles of ions. So the boiling point increases not by half Celsius but half by 3. This is half by 3 to give the total boiling point of the solution is 101 and half Celsius. I hope that you understand the colligative properties of the solution. Thank you for listening.